In this video, we're going to learn about composition of transformations. A composition of transformations is a combination of two or more transformations performed on the previous image. Note that the transformation that maps the original pre-image to the final image is called the composite transformation. When performing a composition of transformations, note that the transformations performed don't have to be the same type. For instance, you could have a rotation that's followed by a reflection, that's followed by a different reflection, that's followed by a dilation. So it's not like you have to do a translation followed by a translation or a rotation followed by a rotation. It can be any combination of any of the transformations. Just a clarification about notation, for every transformation applied, the image gets a tick mark. So if you perform 3 transformations on point A, then you would get A prime, A double prime, and A triple prime. Now we will do a few example problems. In this example, we want to match the composition description with the diagram below. And yes, I did misspell reflection. Okay, now that that's fixed, I want to read the descriptions and match them with the pictures that are given at the top. So the first description is a reflection in line M, then a translation parallel to line M. So what I'm looking for is for figure 1 to be reflected, landing in figure 2, and then I want figure 2 to be translated parallel to line M. So immediately I see in choice C, 1 is reflected to 2, and then 2 is just translated over. So this pairs with choice C. Number 1 pairs with choice C. So for choice 2, I want to look for something that's translated parallel to line M and then reflected in line M. So what I see is for choice A, figures 1 to 2, that happened by a translation, and then figure 2 is mapped onto figure 3 by a reflection. So choice 2 matches with choice A. By process of elimination, we already know that 3 pairs with B, but just to show, figure 1 rotates around this point P, and then it's reflected to give us figure 3. So choice 3 pairs with choice B. For this example, I want to describe the composition of transformations and then write a single mapping rule to get from triangle ABC to triangle A double prime, B double prime, C double prime. So looking at my pre-image, I see that my pre-image looks like it was reflected to give me triangle A prime, B prime, C prime. So notice that points C and C prime are located at the same spot, so that means it must have been reflected over this line, which we know is the line y equals 0. So it looks like we reflect over the line y equals 0, and then I need to figure out how I get from triangle A prime, B prime, C prime to triangle A double prime, B double prime, C double prime. It doesn't look like it's been rotated, and it doesn't look like it's changed size or reflected, so it really just looks like a translation, right? So you go 1, 2, 3, 4, 5, 6 units to the right, and then up 2 units. So it looks like the translation is right 6, up 2, but we have to make sure that works for all of our vertices. So 1, 2, 3, 4, 5, 6, 1, 2. It works for B prime to B double prime. And then 1, 2, 3, 4, 5, 6, 1, 2. So my description would be that the pre-image is reflected over the x-axis and then translated right 6 units and up 2 units. So to figure out the single mapping rule that gets me from my pre-image to my final image, I think the easiest way to do that would be to write the 2 mapping rules that happened and use those to figure out my single rule. So I know the mapping rule for reflecting over the x-axis is xy goes to x negative y. And then since we're translating 6 units to the right and 2 units up, we go from x prime y prime to x plus 6 y plus 2. So I can actually just look at those 2 mapping rules and figure out the single mapping rule. So we're going to go from our pre-image, xy, and if you notice, we're going from x and x plus 6. So in our single mapping rule, we'll have x plus 6. And then we can take our y values and see what's going on here. So we would have negative y plus 2. And so that's what I'm thinking our single mapping rule is, but we need to make sure it works. So if you notice, our coordinates for A are -5, -2, and our coordinates for A double prime are 1, 4. So if we use the mapping rule we think is correct, we can double check with the coordinates from our pre-image and our final image. So if x is -5, when we apply the rule, we get -5 plus 6, which is 1, and then we get negative -2 plus 2, which is 4. So that works. And if we wanted to, we would check the coordinates for B to B double prime and C to C double prime, and we would see that this single mapping rule is correct. On the following 2 slides are the 2 questions you have to answer in the Check-in Composition of Transformations Google form. This is question 1, and this is question 2. This concludes your notes on composition transformations. Here is today's learning target. And as always, shout out to Slides Carnival for sharing this awesome free resource.